In this demonstration, we're mixing two effects. The first is the effect of the acid-base indicator phenolphthalein. Now, you've learned about acid-base indicators already in Module 10. The second effect is the effect of oxidation number, which is what we're studying right now. Here's the setup. I've got a spray bottle, which you see in the upper left-hand corner of the screen, and I've got what appears to be a blank piece of paper. Now, look what happens when I spray from that spray bottle onto the blank piece of paper. I get my name, J. That's pretty cool, isn't it? You can figure out what happened in this part of the demonstration by remembering what you learned in Module 10. The blank piece of paper wasn't really blank. Before the demonstration began, I had taken an acid-base indicator, phenolphthalein, and I had used it to write my name, J. In the presence of acid, phenolphthalein is clear. Well, I wrote it with a little bit of acid in it, so it was clear and you couldn't see it. However, when I sprayed a base on it. In the presence of base, phenolphthalein turns pink. So the writing appeared in pink because the phenolphthalein was reacting to the base that had been sprayed on the piece of paper. Now watch the second part of the demonstration. So what happened here? Well, the first part's probably pretty obvious. I sprayed another compound on the paper, and one of the things that was in that compound was an acid. Well, the acid neutralized the base, so the phenolphthalein went back to being clear because there was no base to make it pink. That's how my first name, J, disappeared. But how did my last name, Weil, appear? Well, before the demonstration began, I had written my last name with another clear chemical called sodium ferrocyanide. Now, that chemical contains iron with a +2 oxidation number. The chemical I sprayed on the paper had acid in it, like I said before, but it also had another chemical, ferric ammonium sulfate. That chemical contains iron with a +3 oxidation number. So the iron that had a +2 oxidation number on the paper interacted with the iron that had a +3 oxidation number in the spray, and the result was this nice blue color, which is actually called Prussian blue. In the second half of this demonstration, then, we used two solutions, both of which contained iron. But because the oxidation numbers of the two iron compounds were different, the result, when they mixed, was pretty interesting.